In today's video, we're going to be learning about titration and travel time. We're going to be using acid today to determine that. So there's really three things that we want to work on today. The first is before we can do the titration, we have to calibrate our devices. So we're going to go through the calibration procedures of some pH meters. And then the next thing is we're going to develop a titration curve, show you how we do that. A titration curve is basically the relationship between the water pH and the amount of acid that's added. It's unique for each water source as well as each acid that you choose to use. Today we're going to be using a little bit of infuric. Then the last thing that we're going to do is we're going to set up a sprinkler lateral and we're going to inject acid at a given rate based on our titration. And we're going to try to get the pH down to around 5.5 out of the sprinklers. So we're going to monitor how long it takes for the acid to reach various sprinklers in the lateral. All right, let's start by first calibrating our sensors. Today we're going to be using a eco tester, pH 2. We've got several of them here. We want to verify that they're all working the same, so that way if we were to use more than one, we should get the same result. So this is widely available. You can buy them pretty much anywhere. This particular unit does only pH, but you're going to turn it on here so you can see this particular unit. See right now it's just reading the air and it says a pH of 8.1, right? But so what does that mean? It really means nothing yet. So we need to get this into some solution to verify that it is calibrated. And then if it's not calibrated, we'll go through the calibration procedure with you as well. So the first thing we need to do is we need to start with some known solutions. So you can see in the background here, this red one has a pH of 4. This green is a pH of 7, and this blue one here is a pH of 10. And so the one you're supposed to start with is the pH of 7. So I'm just going to go ahead and pour a little bit of this. The amount that you're supposed to have is about 1 inch of solution in the container here. So we're going to fill this up to about 1 inch, right around there. And then we can test what the pH is here. So this is still on. It's reading. You can see now the pH is bouncing around all over the place, but let's put it in some solution so it can actually measure here. So you're supposed to swirl it around a little bit and let it sit for a moment. So again, that buffer pH was a 7.0 and it's reading 7.2. So it's slightly high, which means that we should be calibrating this particular unit. So now let's go ahead and check what it is at 10 and 4 here. So we're just going to pour in some solution here. Again, about 1 inch of 10 and 4. All right, so let's go ahead and let's check it in 4. So we'll check our first sensor in 4. You can see there it's reading about 3.5, so it's reading a little low. Okay, let's go ahead and move it back to the 7. Now it's about 7 there. And then move it over to 10 here. So it looks like it's pretty close, but it's a little off. All right, so we're going to calibrate that particular unit. All right, so let's go ahead and go through the calibration procedure for this particular unit here. In this particular one, we're just following the manufacturer's recommendations, just showing you what to do. So we'll start by putting it in the pH of 7 solution. So swirl it around a little bit, let it sit for just a moment, see where it dials in. Might not be able to tell, but there's a calibration button here I'm going to hit. And then it's going to flash cal there, basically saying that it's calibrated. So now it's saying here's what the reading is. We're doing the 7 calibration. So I'm going to go ahead and hit enter, and it's going to calibrate to a pH of 7. So that particular unit is calibrated. And again, trying to get rid of the stuff here. You know, you can rinse these things off with deionized water in between, but probably not very many people do that. So here we go. I'm going to go over here now to the pH of 4. You'll notice in this case it's a little bit lower than 4, so we're going to calibrate it to 4. So we're going to hit the calibration button. It says it's calibrating. The sensor knows that we're trying to calibrate to 4, so we go ahead and tell it, yep, that's what we want is 4. So we hit enter, and so now it's calibrated to 4. So we'll pull that out, again, shake it off here. Okay, bring it over to 10, mix it around in the 10. All right, so it's reading a little lower than 10 here, so we'll go ahead and calibrate to 10 as well. So I'm going to hit calibrate. It says you want to calibrate to 10, right? It's close to 10 there. I say yes. So I hit enter, and it calibrates it to 10. Okay, or pretty close. I mean, again, these are field instruments. They're not going to be perfect. All right, so that means we've now finished our calibration. And so what we'll do here is we'll just go through and see if it kind of nails each of the solutions now. So let's go back to 7. See what we get there. So it's saying 7, right? You got to give it a moment to get it dialed in. So there's 7. We'll go ahead and try it again with 4. There it is at 4. Dry that off and then bring it over here to 10 and see if we get a 10 reading as well. All right, so there it is, 10. So we now have our calibration of our sensor, so now we can use it to do the titration as well as use it for the travel time lab. So just to also let you know, there are other types of testers on the market. This particular unit is a TDS tester, so it will test for total dissolved solids in the water. And there are calibration solutions for those. You can see in this particular case, there's a solution or the concentration that it should be measuring. So the calibration procedure is very similar for these different types of units. I just showed you what it was for the pH meter, but you can also do the same thing for other meters. One last note on these sensors here. You'll notice that I've got this sensor kind of submerged pretty good in the solution, and this is a little bit of a teaching moment. You don't really want to get you don't want to drown the sensors, right? You want the just the electrode piece to be in the solution or in the water that you're testing. So in this particular case, it is waterproof, but for some other devices, they may not be. So you really just want the electrode in, otherwise you might damage the electronics of the sensor. Now that we have our sensors calibrated, we have to go outside to the field and get a sample of water so that we can develop the titration curve. The titration curve is important because it tells us how much acid we need to inject to achieve a given pH in the irrigation water. So I've got just a mason jar here. We need about 500 milliliters. We're going to get a little more than that just to make sure we have enough when we do the test inside. So you might notice here, if I was just take this mason jar and try to get a sample of water, that's really kind of difficult here. So what we got here is a garden hose. All right, so we'll go ahead and put our hose on here to get our... All right, so we got our hose. Go ahead and put this into the container. You want to let the water run for about an hour before you do this, just so that way any dirty water that might have been in the line that's not representative of the water that's actually coming out of the system, is flushed out of the pipes and so forth. So make sure you wait a little while before you collect your water sample. So now we'll use this to do our titration. Let's go ahead and do our titration. Again, the titration curve is specific to the acid that you're going to be using. Today we're going to be using inferic, which is 150016S, and it's 49% sulfuric acid is really what it is. So if you were to buy straight sulfuric acid, they usually have higher concentrations like 78 and 93 and 98% sulfuric acid. So it's a little bit, still sulfuric acid in there, but it's a little less concentrated. So we're going to be using our acid, we're going to be mixing that in with distilled water here, and we'll go through the concentrations that we're going to be using. We got our little stirrer here to stir those together to make a weaker acid. So we're going to take our acid solution and we're going to measure up a little bit of our acid solution, and then we're going to pour that into more distilled water. So we're basically going to be diluting our acid quite a bit. We're actually shooting for a dilution of 1 milliliter of acid per 200 milliliters of distilled water. Once we have our acid solution from the second graduated cylinder here, that's what we're going to be mixing with our irrigation water to develop the titration curve. Over here we have our burette, which has fine resolution and allows us to adjust how many milliliters we drop into our irrigation water. All right, we also have a funnel here, which we're going to use to get the acid solution into the burette. Here you can see the dilution procedure that we followed. It's important to note that the amount of acid that we need to add is so small that you can't just do it in one dose. So we have to split that up and dilute some acid into water and then dilute it again in more water in order to achieve the concentration that we were looking for. All right, so we're going to start by taking our 100 milliliters of infuric, and we're going to be adding that into the 900 milliliters of distilled water. Remember, when you mix these two, you always want to pour the acid in the water. You never want to pour water into acid. So we're going to go ahead and we're going to take our 100 milliliters here. We're going to add it to our 900 milliliters of distilled water, which will give us a total solution here of 1,000 milliliters. So we're going to mix this nice and slowly here. All right, so now that we have our 100 milliliters of infuric mixed in, we're going to go ahead and stir this up a little bit here, just to make sure we have a good solution. All right, now we need to take that solution and mix it with more distilled water. The reason why we're not just mixing this directly, and doing a little bit of dilution is that you'd have to have a really big cylinder that you can measure accurately. And so when you dilute it a little bit, it allows you to get a small amount of acid and a larger amount of water without having to have a big container of water. So now what we're going to do is we're going to take this, let me move this out of the way here, and we're going to mix 50 milliliters of our solution now in with more distilled water. So I'm just going to try to pour this in to our other graduated cylinder here until we get to about 50. So let's see what we got there. Remember, when you read a graduated cylinder, you always want to read to the bottom of the meniscus here. So now we'll take our 50 milliliters of solution here, and we're going to mix it with our 950 milliliters of distilled water. All right, so there we go. And again, we're going to stir it up here, so that way we can get a good solution mix. So now that we have our 1,000 milliliters of diluted acid, we're going to now mix that with our irrigation water and see how the irrigation water reacts to the acid. So we have a link to the book in the description below. This is chapter 18 in the book, and this is figure 18-6. This is what the titration curve should look like whenever we do the titration. What you'll notice is that every 5 milliliters of acid we add, the pH will drop there, and eventually you get to a point where it really drops off, and so you have to mix your irrigation water with your acid concentrations in order to develop this titration curve, which is what we're going to do next. All right, so we have our solution, our acid solution. I'm going to go ahead and slowly pour that into the burette. We need maybe 50 milliliters here, so that would basically be filling this burette up to determine how that affects the irrigation water. So I'm going to slowly fill this up. Looks like we're at about 25. So we're a little above zero there. Okay. So I'm going to go ahead and I'm going to leak a little bit of that out to get us right at zero, so that way we have a good starting point. All right, so let's start with the pH of our irrigation water with no acid solution added. So we'll turn on our calibrated sensor and we will dip it in the water here, swirl it around just a little bit and see what pH we're starting at. So it looks like we have a starting pH here of about 7.2. All right, so let's plot up our first point here. We have not added any acid yet, so this is just the irrigation water, and we found that the pH is 7.2. So let's put that on the graph. So our burette here holds 50 milliliters. It starts with 0, and then as you add the solution to your bowl here, it'll count down how much you've added. So we're going to add 5 to begin with here. So the way you do that is by just opening this valve slowly, and it will slowly leak 5 milliliters of our acid solution into our 500 milliliters of irrigation water. As we get closer, I'll slow it down there. Remember, when you're looking at this, you want to go to the bottom of the meniscus when you're reading this, and so the meniscus is that kind of U shape there. You want to go to the bottom, so we've got that right about at 5. All right, so now we're going to mix up our water a little bit here with our acid solution, and we will take another pH reading using our sensor. So remember, we were at 7.2 to begin with, and now that we've added 5 milliliters of our solution, we're at 6.9. So now that we've added 5 milliliters of our diluted acid, pH is 6.9, so we'll add that to the chart as well. All right, so let's add 5 more milliliters to our irrigation water for a total of 10 milliliters of solution in our 500 milliliters of irrigation water. So there we are at 10. We'll stir it up again and take our reading. Looks like now our pH is 6.6. Now with 10 milliliters of our acid solution added to our irrigation water, we now have a pH of 6.6. We're going to continue adding 5 milliliters of our acid solution to our irrigation water until we achieve a pH below 3. We'll time lapse this a little bit for you so you don't have to watch the whole process. Here's our final graph after completing our titration. You can see that we ended up adding 65 milliliters of our acid solution to get the pH below 3.0. While this graph does look very similar to the one in the book, it is dependent on your irrigation water and the concentration of acid that you're using. We had a total of 12 sprinklers running in the field. The total flow rate from those 12 sprinklers was 75 gallons per minute. And let's assume that we want a target pH of 5.5 out of those sprinklers. To achieve that, we need to look at our titration curve here, and we're going to find 5.5 on the chart, and then we're going to look down and see how many milliliters that takes. And as you can see, it's 40 milliliters of diluted acid to achieve a pH of 5.5 out in the field. So using the 40 milliliters of diluted acid at a rate of 1 milliliter of acid per 200 milliliters of water, that gives us an undiluted acid concentration of 0.2 milliliters in our 500 milliliters of irrigation water. So that means that we have a very small amount of acid per milliliter of water here of 0.004, which is why we did the two-step dilution. Knowing that the flow is 75 gallons per minute for our sprinklers and using that small acid concentration there, we see that we will need to inject about 113 milliliters of acid per minute. All right, so we're going to start sucking in our acid for our test out here to determine the travel time. We're going to be using a Mazy Venturi, and we've got this valve dialed in here to give us about 3,000 milliliters a minute. Remember, we need to inject at a rate of about 100 milliliters a minute, but that's very hard to do with the Mazy. So what we've got is a tank over here that's set up with the proper amount of water, and our 3,000 milliliters of acid is going to be mixed into that so we can inject at a higher flow rate, so that way we get accurate readings here. We're going to start by making sure that it's calibrated using these graduated cylinders, and then once we got it calibrated, we'll just stick it in the tank, start sucking it out there, and we'll start our test. All right, so remember, you always add acid to water, so we've got our water in our tank, and now we're going to go ahead and add our acid. Nice and easy. Remember, we were using infuric. So we're out here today at Cal Poly's campus, the Irrigation Training and Research Center, in our irrigation practices field. We've got 12 sprinklers set up here today, and we're going to be doing the travel time test to determine how long it takes for the pH to change at various sprinklers along the lateral. We're going to test the first sprinkler, the 6th sprinkler, and then the 11th out of the 12 sprinkler. The reason why we're not going to test the 12 sprinkler is because the velocity in that line is so low supplying that last sprinkler of water that it'd take a really long time to show up there. So here's an example from the first sprinkler on the line. What you can see is that every 30 seconds she's collecting a water sample and then lining it up along the pipeline there so they're kept in order. We will use these to determine what the pH is as time goes on, and then we will plot that up for you. So here's a time lapse of us collecting the data from one of the sprinklers out there. We're collecting data from 3 sprinklers, sprinkler number 1, number 6, and number 11. We'll gather that data and then we'll put it together for you in a chart. Here's the chart outlining the travel time to our 3 sprinklers out there today. You can see that it took approximately 5 minutes for the pH to begin to change at sprinkler number 1, which is closest to the pump. It took about 6 minutes for the pH to change at sprinkler number 6, which is halfway down the lateral. And then it took 9 minutes for the sprinkler or the pH to change at sprinkler number 11. So this is just to show you that as more and more sprinklers are on down the lateral, less and less water is traveling down the lateral, so it takes longer for the pH to get there. And so this would also be true for any fertilizers that you would be injecting. It takes longer for the fertilizers to make it to the end of the hose than it does the beginning of the hose. If you want to know a little bit more about travel time, you can look at chapter 7 in the book found in the description below. Hopefully this covered some of the information about calibrating sensors, what a titration curve is and how you develop it, as well as how long it takes for chemicals to reach various points in the field. Check out our other videos in our fertigation series, and thanks for watching.